Hello. On this lesson, we're going to be converting rectangular coordinates to polar coordinates. Let's start by defining what a point is in polar form. Any point on the graph can be represented in rectangular form or polar form. Polar form is when we describe the point by the angle that's created with the x-axis and the distance r from the origin. If we drop a perpendicular line from our point to the x-axis, then we create a right triangle. And that right triangle has sides x, y, and r for the distance from the origin. And y is the height, and x is the horizontal distance from the origin. Theta is the angle created with the x-axis. And we can see by Pythagorean's theorem that r squared equals x squared plus y squared. And we can also write that as r equals the square root of x squared plus y squared. So these are two equations that are going to be very useful to us in converting rectangular to polar form. So let's put that here and let's take a look at theta. As we can tell from the triangle, the tangent of theta is going to equal y over x. So if we can rewrite this as theta equals the inverse tangent of y over x. So these are also formulas that are going to be very useful. So let's move that. Now let's take a look at an example. Find the polar coordinates of the point with the following rectangular coordinates. So we see that the rectangular coordinates are -3 and 3. So we're in the second quadrant, and we're trying to find r and theta. Since x is -3, we know the bottom of our triangle is left 3 units, and we're going up 3 units to give us our point. So if we use our formula r equals the square root of x squared plus y squared, we can simply plug in the -3 and 3 and get r equals the square root of -3 squared, which is 9, plus 3 squared, which is also 9. And you're going to notice that it doesn't matter whether it's positive or negative when finding r, because we're going to be squaring them anyway, so they'll come out to be positive, which makes sense because we're talking about the length of a side of a rectangle. When we simplify that, we get r equals 3 square root of 2. Okay, now let's take a look at theta. If we recall from our formula, tangent of theta should equal y over x. But let's take a look at our triangle and notice that we have the reference angle here, which is going to be 45 degrees or pi over 4, since we have an isosceles triangle. So therefore we're going to have a 45, 45, 90 triangle, and we know that if this angle is 45, then we know theta must be 180 minus 45, which would be 135. So if we were in degrees, we'd be talking about 135 degrees. And if we're in radians, we'd be talking about 3 pi over 4 radians. So let's see how we get another alternate way of getting that. So if we take the inverse tangent of each side, we get theta equals inverse tangent of 3 over -3, which gives us the inverse tangent of -1. And the inverse tangent of -1 is defined in the first and fourth quadrant, so it would be negative pi over 4. So since we're in the second quadrant, we need to add 2 pi to that, and that gives us 3 pi over 4, which is the 135 degrees that we just mentioned. So therefore theta is 3 pi over 4. And our point, negative 3, 3, when converted to r theta, goes to 3 square root of 2, 3 pi over 4.